Good morning. How's everyone doing? Just that's right. Still sober. Hi, everyone. My name is Mark Brown. Welcome to BRK228 Real-Time Analytics and AI Apps with CosmosDB in Fabric. My name is Mark Brown. I'm a product manager on the CosmosDB team. I'll be joined in a little while with 𝗦𝗽𝗲𝗀𝗀𝗀𝗀, who's one of our teammates for CosmosDB in Fabric. If you're not familiar with CosmosDB, let me go over some of the features and capabilities for our service on Azure. So CosmosDB is Microsoft's distributed NoSQL database on Azure. Some of the key features and investments we make in Cosmos as a database service on Azure include vector search. Cosmos provides native vector indexing and search using DiskANN, which was developed by Microsoft Research. And users with DiskANN can query billions of vectors very efficiently and very cheaply against their containers. In fact, we provide industry-leading performance for doing vector indexing and search within Cosmos. We also provide full text and hybrid search capabilities with re-ranking as well. And users can start small. If they want, they can start with serverless instances. We're unique in the industry. There's maybe only one other competitor in the industry offering a serverless vector-enabled database, and we're the only ones in Azure providing serverless capabilities for vector database in there. So users can build and start small and pay only for what they use with their databases in Cosmos. We also provide deep integrations into all the leading agentic frameworks. That includes Microsoft's Agent Framework, which you heard about this week, as well as LangGraph and many others. Second, Cosmos, unlike other relational databases that you might be familiar with, is a scale-out database. We don't grow up. You don't get larger instances. We just add additional nodes or partitions within Cosmos. So we're a sharded database. Unlike other sharded databases, though, we do all the partitioning automatically for you. You pick a partition key, say like a customer or a state or whatever, and then we handle all of that partitioning behind the scenes for you automatically. We also store all the data for your database on the same cluster as the compute. Now that provides very low latency, in fact, the fastest latency for any database in Azure, and we back that up with an SLA for less than 10 milliseconds at P99. Combined with our scale-out capabilities means you're going to get single-digit latency on your data, whether your database is a megabyte in size or many petabytes in size, which is also very unique for any database anywhere. We also provide native regional replication to every region within Azure. And this affords 5 nines of availability, which is also unique among databases within Azure. You can also configure it for active-active, so all of your regional endpoints can accept writes. And this can give you an RTO of 0 for a database within Azure. Third, we're a JSON database, NoSQL JSON database. So we provide a flexible, schema-free design for your applications. And this is advantageous because it allows you to evolve your applications over time and make changes to your database with 0 downtime. You don't have to take down your database and rebuild indexes. We also automatically index all of your data. So as you add new data or change your schemas over time, we automatically will pick that up and then index that for you automatically. We also provide a dynamic autoscale feature. So as your databases scale out or up, both within the region or in different regions, you're only going to pay for those partitions and those regions that your database scales up. Finally, we're fully integrated across the Microsoft ecosystem. Of course, Microsoft Fabric, that's what we're here to talk about today, but also across Azure's application platform services, so app services, functions, Azure Container Apps, Azure Kubernetes services, et cetera. And of course, we're also integrated into Microsoft Foundry. To highlight our scalability, OpenAI is one of our largest customers and a key customer of ours. OpenAI runs ChatGPT on Cosmos. They store all of their chat history on there, all their memories, and they're running additional workloads on there as well. Now, OpenAI picked Cosmos for a few reasons. First, as a NoSQL database, OpenAI could evolve rapidly, and that was important for a new service like ChatGPT. They never needed to take ChatGPT down to make changes to their schema or to their application. Second, OpenAI had been running on open source relational databases prior to adopting Cosmos, and they struggled with manually having to manage the sharding as they kept on growing. So Cosmos's automatic partitioning allowed them to define a partitioning strategy. In this case, it was a user. And then we took care of the rest and allowed them to scale seamlessly. Now, once on Cosmos, they were able to grow to, now they're over 8 petabytes in size for data under management and routinely run over 200 billion transactions a day. And they do it all on a single Cosmos database, which is quite impressive. So Cosmos is well positioned for this world of AI, and we see it from our customers constantly. But to truly unlock that power, organizations need to understand how they can combine their transactional data with their analytical data so they can get the historical insights that help drive those decisions. And traditionally, these things have been separated, and that's a problem, not just for AI applications, but for business in general, because they're going to thrive on that speed and that depth with which they can make those decisions. So with that, we are proud to announce the GA for CosmosDB in Microsoft Fabric, making it easier to manage your data easily at scale and optimized for AI. CosmosDB in Microsoft Fabric uses the same engine and infrastructure as Azure CosmosDB, but it's tightly integrated into Fabric. It provides that same native JSON support, which is ideal for semi-structured or evolving data models within your apps or within your analytics. And it provides that same automatic and instantaneous autoscale, and is the choice of Microsoft's largest and most demanding workloads in Azure. Cosmos in Fabric provides low latency regardless of the database size and simultaneously supports massive concurrency from users. And this makes it ideal for serving insights from your analytics directly to your users or even back into your applications themselves. Cosmos in Fabric really amplifies what is great about combining an OLTP database in an analytics platform, providing customers with a bidirectional platform for operational and analytical data, bringing applications and analytics together inside a single stack, and easy to provision, easy to manage, and all unified within your Fabric capacity. We're also happy to announce the GA for Azure CosmosDB mirroring. Now, mirroring in Cosmos provides that same bidirectional operational and analytics experience customers can enjoy while if they were using CosmosDB in Fabric for their accounts that are in Azure. And so the benefit here is it allows customers to seamlessly integrate existing applications and workloads with the analytical capabilities within Microsoft Fabric. Customers can choose which data they want to replicate into the OneLake using mirroring, and that gives them complete control over which data they want to build analytics on. It also provides true HTAP capability with complete workload isolation. And this allows customers to provision and manage separately their operational from their analytical workloads and keep them completely independent of each other. And this gives customers a choice, and frankly, the best of both worlds. They can get the SLA-backed single-digit millisecond latency and also the 5 nines of availability, combined with Microsoft Fabric, making it even easier to bring existing operational workloads into the Fabric platform. So some of the features we're announcing with CosmosDB mirroring include that container-level support, so customers can pick individual containers of data within their databases that they want to replicate over into OneLake. They also are going to get all of the great AI features they've come to expect for Azure CosmosDB, including all of the native vector indexing, full-text search, hybrid search. Cosmos as a JSON data store, of course, we store data hierarchically within documents. So having auto-schema inferencing and support for T-SQL's OpenJSON provides customers the flexibility to be able to query that data from their SQL analytics endpoints within Fabric. CosmosDB mirroring has been in preview for about 18 months. And over that time, we've built in a lot of reliability and a lot of stability from those customers who have put it through its paces. We're also announcing more improvements for mirroring performance. So now customers can get up to 2.5 terabytes a day of mirroring performance for their data in their operational workloads as they replicate over to the OneLake. And then finally, not ready yet, but in about 2 weeks, we'll announce support for VNet and private link support for their CosmosDB endpoints so they can properly secure the networking for those applications within Azure. So let's go back to the CosmosDB and Fabric. I want to talk about some of the integrations and some of the capabilities within there. So kind of the beauty with replicating your data with that zero ETL capability from your operational workloads into CosmosDB or into Microsoft Fabric is the ability to be able to do cross-database queries. Now this allows you to query your Cosmos data and your SQL data and all of your data, frankly, all in a single place. So instead of copying data across systems, you query it where it already lives, in the lake. And that means lower costs, less duplication, and always up-to-date results. You can also blend different types of data. You can blend your JSON data from CosmosDB with structured data coming out of your SQL databases. And because it runs directly on Fabric and OneLake, this architecture is going to remain simple. There's no extra pipelines. There's no middleware that you're going to have to maintain as part of this. And the result here is you're going to get faster insights, access to your data much more quickly, fewer moving parts, and just an easier path for teams to be able to take their operational data and analyze it to get the insights together. Fabric Notebooks gives you a single environment where you can work with your CosmosDB data using Spark or Python or even T-SQL and not have to move your data around. You can explore and transform and analyze all of the data using the languages your developers and your data scientists and others are comfortable with and do it all in one place. And this makes it simple to blend real-time operational data with the broader analytical workflows in the same workspace. And this gives you flexibility. You can use Spark for distributed processing, Python for doing custom ML or data cleanup, and then T-SQL you want to do your cross-database queries and project your data back out. And this lets teams use the skills that they know today while smoothly orchestrating all of these different pieces together across the Fabric ecosystem. CosmosDB and Fabric gives you that real-time semantic search directly on your data in CosmosDB. No separate vector databases, no extra search infrastructure. And this makes it easy to build chatbots or recommendation engines and provide a natural language search experience over the data in your apps. And since Fabric bridges analytics and operations, this makes it easy to operationalize your analytical intelligence. The result is a much richer search experience and a much faster path from analytics to production AI. So to give you a little view of what this looks like, I'm going to invite Jai back up, and she's going to give you a little sneak peek at doing semantic search over data in CosmosDB and Fabric from a Fabric notebook. And let me switch over to here.
Awesome. Hi, everyone. So before I jump into the notebook that covers vector search, I just kind of want to walk through a CosmosDB database artifact here. So as you can see on the home page, it's very easy to get started. We have some sample data that you can use and a link to our sample gallery that shows various use cases. And this sample data reflects a technology e-commerce business, more specifically storing their product catalog and their customer review data, and that kind of lives side by side in a container. The vector version of this sample data is the same exact data set, except the products are vectorized. So I'll show that right now. So for the sake of this part of the demo, we'll only focus on the product document type here. So we have kind of all these different attributes here for a product, but I want to kind of point out this vector down here, and this kind of encapsulates all of this sort of data for this product. So getting started with the database is super easy. You just go over to the connection, grab this connection endpoint, and then you're ready to kind of plug that into your SDKs and clients. So I'll switch over to the notebook here, and I'll kind of walk through what we have. And you can find this in the samples gallery, like I mentioned.
Yeah, I'll show you a link to our samples gallery. We've got a ton of samples to help everyone get started using all this sample data that we've got provided right within the portal.
Yeah, so the first cells are just installing packages, configuring our endpoint. So we see where we put that endpoint that I just copied, our database name, our container name. We're doing some sort of token credential authentication in this. cell here so that we can instantiate these different clients that we need. And then we have this function that makes an OpenAI call to create an embedding for some text input that we send. And then we return that. So we can actually see this tested here when we run hello from Fabric notebooks. We see this sort of output of different vectors. And then this is kind of the main part of the notebook where we actually perform the vector search here. So we're taking in that search string, we're putting a similarity threshold, and we're also saying how many results we want to see. So we're taking that search string, creating an embedding for it, and then we're running a Cosmos query where we pass an embedding into the vector distance function here. This essentially calculates that similarity score across all of the products in our container. So we can also filter by that similarity threshold here in this where clause, and then we can order by most similar products, so we have the most relevant search possible. So then we can see this in action here in this cell. So for example, if we wanted to search for a gaming mouse, we can see some products that populate down here. If we wanted to make it a bit more strict, so maybe we only want to see products with 0.8 similarity score. Oh, let me see if we...
You had to rerun your cells up
Yeah. Let's go ahead and see if we can rerun this.
See if you just go run all, see what happens.
Yeah. Let me see here.
Oh, it is, it's running.
Yeah. But in the case that the kernel was set up, you would see that less results would show up when we kind of change the similarity score here. So we'll give it a second to kind of run through, and we'll see the output here. So we see that there are less results that pop up here, and we can continue to search for the sake of time. I'll pass it back over to Mark to continue talking through the rest of the features that we have.
Okay, looks good.
Awesome.
Thank you very much.
Thank you so much.
Thank you, Jai. Okay, so more features and more integrations for Cosmos DB and Fabric. Cosmos has excellent integration with a relatively new feature called user data functions in Microsoft Fabric. UDFs make it easy to build these translytical task flows with Fabric, allowing users to act on their insights more quickly. UDFs let you embed business logic directly in Fabric using Python. So you write it once, and then you can reuse it everywhere without having to manage separate services. And you can call these functions from your notebooks or from pipelines and even Power BI, which I'll show you in a little later. And this gives you kind of a consistent, repeatable operational experience for your Cosmos DB data and all of your data within Fabric without having to duplicate code. Finally, you can expose these functions as REST endpoints. And this allows external applications to trigger complex operational semantics on your data in Cosmos or your other data within Fabric without having to have any separate compute or libraries or have any additional security on top of it. Fabric's Zero ETL makes it easy to integrate operational data with your analytical data in OneLake, including being able to land it in the bronze layer for your raw data sets. From there, however, you can take that data using notebooks or Spark jobs or data flows and then apply business logic on it and joins in your silver layer and preparing that data for your data sets in gold. And then once in gold, you can serve that to your SQL endpoints or your reports in Power BI, or you can push that data back into Cosmos DB and use that as a low latency serving layer for your applications. And that bidirectional support supports everything from dashboards to real-time operational intelligence, and all built on that same governed Medallion pipeline. Fabric integrates directly with GitHub and Azure DevOps. And this is a great new feature. So all of your Cosmos artifacts, including your notebooks, your pipelines, your lakehouses, all of it can be versioned and branched and reviewed just like your code is. Deployment pipelines let you parameterize your connections. So you can promote your Fabric artifacts from, say, dev to test and all the way into production without having to maintain connection strings and all of that information. And because everything moves together, you can deploy all these artifacts in a coordinated and governed way, reducing errors and helping to speed up releases. Of course, mirroring data from Cosmos into OneLake really is incredible for what it unlocks for building analytics. But it doesn't stop there. databases are uniquely suited to do things that are difficult in an analytics platform, such as serving data with either extreme low latency or with very high concurrency or directly into applications. And this is where CosmosDB shines. As a distributed NoSQL database with automatic and instant autoscale, it's well suited to serving analytical data directly into customer-facing applications or other event-driven processes and services. And it does this using our Spark connector. And with it, you can push large volumes of data using Spark's compute engine for high-performance reads, writes, or queries and transformations. The connector also natively integrates with Spark Data Frame, Spark SQL, and Spark's Catalog API, and support for schema inferencing and working with JSON data. And it supports both the batch workflows as well as the real-time processing through Spark streaming. So you can build reverse ETL for fast analytics or real-time personalization or recommendation engines and do so at really massive scale. CosmosDB is optimized for customer-facing workloads, and Fabric builds on that foundation to apply analytics to those workloads. For AI applications, you can utilize CosmosDB's vector search to do semantic search and build multi-agent applications. For core transactional workloads, you can build carts or checkout services, pricing engines, fraud detection, or real-time inventory solutions. You can also deliver real-time recommendations for vectors generated from collaborative filtering, or support IoT scenarios by ingesting large amounts of telemetry and then driving downstream apps and processes using change feed in Cosmos. And all of this is grounded in Cosmos' foundation for high availability, low latency, high concurrency, and the elastic autoscale. So Cosmos has always been used for all of these customer-facing applications, but it provides a ton of value for all of your analytical workloads as well. You can vectorize lakehouse data in Fabric and then write that back into Cosmos to run semantic search over your analytical data. You can combine Spark streaming with CosmosDB change feed to process events to build things like hot path analytics and automated alerts. You can build ML workloads and train models in Fabric using transactional data, then push those predictions and the enriched features back into Cosmos for real-time inferencing at massive scale. Again, all of this is built on that foundation of that high availability, low latency, high concurrency, and our autoscale throughput. Customers who've been using Cosmos have really loved it. They enjoy its flexibility and the ability to be able to do and take transactional data and put it in their analytics with zero ETL. And they're building really cool solutions with it, whether it's SaaS platforms or building agentic applications to streamline applications or operations, or just simply to help them get the insights they need to run their businesses better. So I want to spend the rest of this time, I'm going to leave some time for Q&A. So we got about 15 minutes. And Jai, why don't you come right back? We're going to do a series of demos. So let me kind of go over to my machine here. So Jai showed you a little earlier some sample data set. So in this demo, Jai and I are going to play product managers, kind of like what we do in real life, but for a fictitious e-commerce retailer. And we've been charged with trying to do revenue optimization. So we're going to take this data set that we've got, which is a product catalog here. And you can see we've got product data in here. We've also got price history for these products. And then in that same container, we also have customer reviews. So they've tasked us with taking the product catalog and the price history with the customer reviews and then analyzing the correlations between pricing and customer reviews and see if we can come up with better pricing strategies for some of our products in here. They don't trust us with sales data, apparently, so we're not that trustworthy. So I'm going to take this data here, and again, this data here and the samples and the demo we're going to show you is all available on our samples repository, and I'll show you a link at that at the end. So we're going to start with our sample data here, and I've got it here in Cosmos. The first thing I need to do is I need to create some views. So I'm going to go over to my SQL Analytics endpoint here, and all of my data from Cosmos is automatically pushed over here into our SQL Analytics endpoint. And I need to create some views. So I've got some queries down here that I've written. This is a product view. We're going to use this because we want to filter just for the products. We don't want the customer reviews in there. So let's go. I'm going to create this view. And then I've got another view here. This view takes and provides kind of a change by change comparison between price history and product reviews. So, and we're gonna take and make a really cool looking, pretty graphic out of that. So I'm gonna run that one here. And then the last one is I have this monster one here. And this is going to create a couple of different CTEs, and we're going to do all of our processing of our data so that we can create standard deviations on the price changes and the review changes. And then we're going to build our Pearson correlation on top of that. So let me kind of walk through here. So I have this one CTE. I'm going to join products with the reviews. And then I want to calculate results, but I want to compare them by category because we're an electronics retailer. We have computers, which are really expensive. And then we have things like a mouse and a webcam and like a stand. So I don't want to compare the pricing between or across categories. I want to keep them within the category. And so we're going to do things like relative price position within here, price to average ratios, category price percentiles, satisfaction levels. There's lots going on inside this view here, value assessments. Let me keep going down because one of them in here, I'm going to calculate the standard deviation. So here's where I'm going to create my category price standard deviation and the rating deviation. So let me go and I'm going to run this one here. And then what I should see is I've now got my 3 views all created here in my SQL Analytics endpoint. And then the next step from there is we're going to go and create a semantic model on top of that. I think we kind of went ahead and did that. So this is like an infomercial where we put the cake in the oven and then we pull it out. It's already done. So Jai, let me go back over to you because I think you've been busy working on this report.
Thanks, Mark. So we'll jump straight into the semantic model that Mark just created on top of all these views. So this semantic model uses direct lake storage mode and is connected to our SQL Analytics endpoint of our database. So for the sake of time, we already have some sort of pre-populated relationships between these tables. And we also have some pre-existing measures here. They kind of serve as some of the building blocks in our reporting in the next few steps. But we are missing one key measure, and that's the correlation coefficient. And that allows us to see that correlation between the price change and review score over time per category. So I'll go ahead and add that now. And then once that's done, all of our data is in place. We can either create a new report here. For the sake of time, we've pre-populated a report. And you'll see some of these elements already in the report. I'll go into edit mode here. So these cards here, they give us a quick snapshot into our metrics, and they actually derive from the measures that we created in the semantic model here. We also have, and let me switch over to this first page, we also have this category slicer, and this allows us to kind of drill down further if we wanted to kind of look at a specific category. But we see this big empty space here, and that's not very useful for anyone. So I'll create a clustered bar chart here to allow us to easily visualize that correlation in each category. And these views make it very easy to build this reporting. So I'll do the categories, the y-axis, I'll do the correlation coefficient as the x-axis, and then this kind of serves as sort of the graph that we need. But if we wanted to make it a bit prettier, we can add data labels. We can even make it a bit more visually intuitive by adding some color here, maybe jazz it up a little bit. Let me make this red for negative correlation, add a neutral color here for no correlation, and then for a strong positive correlation, we'll make this bright green, like so. And yeah, let's see. Oh, here it is. That's what went wrong. There we go. So now we can kind of easily see the sort of categories that we would want to maybe consider rethinking the price strategy for. So if we wanted to dive into a specific category further, say we wanted to look at high-end chargers, for example, they have a pretty good correlation. We can select it here and then switch over to the second page. So the second page has a lot of the same elements, except now we have a product table, and we can kind of drill down into a specific product SKU. Again, we have sort of this blank space, and we want to visualize the trend line for the price change and review score over time independent of each other, so we get more of a granular view of both of those metrics. So I'll go ahead and create that now. I'll use the price review change view, and again, that makes it a lot easier to build this out. I'll use the data as the x-axis, price as the first y-axis, and then stars as the secondary. We'll take the average of both of these. And then that's pretty much what we need. So right now, it's a bit hard to interpret. But if we were to drill down on a specific product, say the Pro X950, we can see over the past year what has happened with the price and the review scores over time. So we see that it's increased from 3 to 4 stars in the last year, and price has increased from 80 to around 120. So maybe we want to rethink about the price strategy for this.
I see an opportunity there. What it looks like happens is the price goes up and customers like it more. So
that makes a lot of sense.
My job is to optimize revenue. What do you think I should do with that?
You should definitely hike up the price.
Let's take a look at what we got. So I took your graph there and I went into Power BI Desktop and I used this new text slicer because what I want to do is I want to analyze the correlation between these products, and when I see stuff like this, my boss is going to love this. We'll give that a second to warm up there. Come on there, buddy. Oh, I see the little spinning little ball there. Come on, there we go. Yes, there we go. Revenue maximization opportunity here. So what do I want to do? I want to use this report, and then I want to update the price for products when I see a really strong correlation like this. So I've got a new text slicer here where I can enter in a new price. The next thing I need to do is I'm going to add a button. Oh, but first, how am I going to change the price? I've got to write some code to do it. So you know what? I've got this user data function right in here. So this one is called price review correlation UDF, and then I created a new function in here and I called it update price. So there's some connection stuff in here for Fabric, but the parameters I'm going to pass into this thing, I need to pass in my category name, so because we're partitioned by category and we want to find an individual product, so we're also going to pass in the product ID, and then I'm going to pass in a new price within there. So that's my function definition right there. I've got some connection stuff in here. Within the function, I'm going to do 3 things. The first thing I need to do is I need to get the product. So I'm going to use that information, the category and the product ID, and I'm going to go look up a product out of my product catalog. I then want to update the price. So I'm going to take the current price for that product, and I'm going to pass in the new price that I'm going to bring into it. Remember, we had a price history array within that product catalog. So I want to update and append a new object within there. So I'm going to add the date for today, and I'm going to add the new price. So here I'm going to, my product price history, I'm going to call append to it, and then I'm going to pass in today's date and a new price. And then finally, I want to update the product. So I'm going to call replace item here, and then that'll update the product within our product catalog. Okay, so our function's done. Let me go back to my report right here. And let's go, and I need to call a button so I can edit it. So let me go back into edit mode here, and let me find the buttons. Here we go. I'm just going to create a little blank button here. And let's drag this guy down. We'll put him right next to our new price. And maybe I can put some text on him here. So I'll put update price in here as my text name. Make that a little bigger so folks can see it. That looks good. All right. Well, it looks good, but now I got to do something. So I'm going to enable this action on that button, and then I'm going to select data function here at the very bottom. And then I need to go and find my UDF. So let's go find my workspace. And there's my function, price review correlation UDF. And then the name of my function is update price. Okay, so I'm bound to that function. Now let's pass in the values that I want. So we're going to go back to the views we were using. This is the product view that I created, the first one, and I'm going to grab the category, right? And that's that view that powers this guy in the middle here. Okay, and then I need to get the product ID out of that view for that current product. So let's grab the product ID. We'll select that. And then last, I want to grab the new price out of our little text slicer here. So I'm going to select new price right there. And then I think this is working. So let's go. I'm going to try this right here in edit mode. We'll go and I'll select my product again. That looks good. So what did you say that was? $120-something, $119.99.
Yeah.
And look at those review scores going up. Let's see, I think I can get another 20 bucks out of folks with this product here. Let's try this. I'm gonna make it $139.99. And did that run? Let's see. Click the thing. Oh, I did select the product. Is it running? Here, let's save our report. And check you again, new price, and update. Oh, I gotta hit control. Oh, yeah, because I'm in edit mode. There it goes, there's a little spinning thing. Thank you, Power BI user. And request submitted. Okay, let's go. I'm gonna go look in my database. Yes, I wanna save that report. So I can, and let's take a look at our price here. And there we go. I got a new price in my array here, $139.99, and the current price here is $139.99. So, you know what? I think we deserve a raise because we're maximizing revenue for our company. We're keeping our jobs. So, all right. How'd you guys like that demo? Yeah? Okay. All right, let's wrap it up. So, if you want to learn more about Cosmos DB and Fabric, we have some great resources for you. Of course, we've got our docs that are available now, AKAMS/CosmosDB docs. We have a great samples gallery. Maybe I'll show you a quick little sample of that. It's AKAMS/Cosmos Fabric samples. And then we have a YouTube channel, AKAMS/Cosmos Fabric videos. So let me wrap up. We have some additional sessions here. There's a hands-on lab right after this session, by the way, if you want to get some of your hands on running Cosmos DB and Fabric. Let's see. Build real-time. It's got the same name as this thing, Lab 534, and it's down in Moscone South, level 3, room 306. And this thing still shows you can RSVP, so if you're interested, LAB 534, you can come get your hands on this and try out some new stuff as well, including doing Spark notebooks and doing
event streams and real-time data.
Yep. So some great stuff in there. So that's it for us. We've got about 5-7 minutes. If you have any questions, feel free to come up at the top. Oh, before I do though, hold on, let me show you our samples gallery here as well. By the way, you can find the samples gallery right in the portal. So if you click on sample gallery right here, that's going to open up all of our samples. We've got samples for fraud detection, how to do container and throughput management. The price review Power BI demo you just saw, that's in there. We also have one that's using a Spark notebook, some simple Python CRUD, simple queries, how to do Spark and Scala. All the user data functions we have in there, vector search samples in there. That was the earlier demo you saw in there. So all of this available within our GitHub repository, all there to make it very easy. They all, I think almost all, use the sample data set that's available right there in the portal, so you can go and just click on sample data and then grab a notebook and go and just connect it and run it in there. So I want to make it real easy for you to go and try and explore Cosmos DB and Fabric.
Yeah, and if there's any suggestions on some samples that you want to see as well, feel free to come up to us and let us know too.
Or just, you could put an issue in the GitHub repo.
Yeah.
I'll assign it to Copilot, and it can go and create it for me. Okay, that's it. Thank you very much. We'll take some questions.